Now let's go ahead shading some region of problems involving three sets diagram. So as you can see, we're having three different diagrams on my screen. Now the purpose of this is just to make sure that you guys get this once and for all, because we're going to be making use of one as our final result. We're going to be making use of the other two as a what? As a reference on how we got the answer or how we get to the answer. So let's start by providing the region that is to be shaded. If we are to shade A intersect B, intersect C, where are we to shade? If at all we are to shade this particular region. Now the first thing we need to consider doing is to shade the portion or the region of A intersection B. Okay, now let's consider the first diagram over here, which is this. Okay, so let's use this to shade the region of A intersection B. Okay, so where are we to shade? If we are to shade A intersection B, let's say this first circle denotes A. Let me write it inside. So this denotes A, this denotes B, and this denotes C. So A intersection B, it turns out to be this little portion over here, even with the fact that it took some part in set C, but we have to shade it all together because that is what A intersection B is. That is the region of A intersection B. Now the next thing we need to do is to shade the region of set C alone. Where are we to shade? If we are to shade the region of set C alone. Okay, so if this denotes set A, this B, and this C. So in order to shade set C alone, then we need to shade all the region of set C. Now, I want you guys to pause the video and try to figure out if there's any common region being shaded in between the first diagram and the second diagram. Is there any common region shaded between them? Yes. The fact that the little portion over here is being shaded, okay, in the second diagram, and at the same time is being shaded in the first diagram. So therefore, the region to be shaded for the operation A intersection B intersection C is this little portion over here. Let me use this slightly pen so that it won't exceed where we want to shade. So this is where we are to shade for A intersection B intersection C. So hopefully you guys are now able to figure out where we are to shade. Okay, so I will recommend you guys, in case you are being tested on this in either your test, exam, or assignment, okay, try to do this one after the other. Okay, even if you want, you can split this diagram. Okay, as soon as you just make sure that you know what you are doing. Okay, so now let's try to work out more example. So what if you have to shade A union B intersection C? A union B intersection C. Okay, so unlike the previous example, we're going to be making use of one diagram to shade the region of A union B and making use of the second one to shade the region of C. Then we turn it, then we find their what? Their intercept, that is their common region being shaded. Then that will be our final result. So let's go ahead. Okay, so if this first set is set A, and this is set B, and this is C, A, B, C, where are we to shade for A union B? What does A union B really means? A union B means either A or B or the both. So therefore we are shading both region of A and B, including their intercept. So therefore for A union B, we have to shade this portion over here. Okay, I think it's pretty okay this way. So the next thing is to shade set C alone. Okay, so we have done that earlier. We just need to shade all the portion of set C. Now, pause the video and take a look if there is any common region being shaded in the both diagram. Okay, it turns out that this little tiny space, this is the first one, this is the second, and this is the third, and at the same time, first, second, third, these regions are what are common. They are commonly shaded in the both diagram. So therefore, those regions turns out to be what? A union B intersection C. Okay, I don't want to use the bold pen, but it might exit the point I want to shade. Okay, so I just merge this. So this should be the little portion to be shaded for A union B intersection C. So that is if this is set A, this is set B, and this is set C. Okay, now let's move forward. Let's try to work out more example. Okay, now what about A union B prime intersection C? How can we figure out the region to be shaded for such operation? A union B prime intersection C. Okay, now the first thing we need to do is to figure out A union B. After that, we figure out its prime. Then we now check if there's any common region being shaded in the prime and set C. So let's go ahead and shade A union B. So we said if this is set A, this is set B, this is set C, we have A, we have B, we have C, we have A, we have B, we have C. So for A union B, we're going to be shading all this portion over here. Okay, all these regions are going to be shaded for A union B. Why for A union B prime? Okay, hopefully you guys are following. Okay, because I'm not writing the operation. Okay, but hopefully you guys are getting where I am shading. Okay, regarding to the particular operation. Now let's use this second diagram to shade A union B prime. What does A union B prime really means? It means all the region, okay, excluding the regions of A union B alone. So where are the regions that exclude A union B alone? So all these regions over here are said to be the prime of A union B because they are excluded. They didn't reach the portion of A union B. So this is A union B prime. Okay, now the next thing is to figure out set C. Okay, so I will be what? I will be using this third diagram. Okay, this third diagram to shade the portion of set C. Okay, so set C will be what? It will be everything over here. Now let's try to figure out if there is any common region being shaded within these two diagrams. Is there any common region being shaded in these two diagrams? It turns out that the little portion of set C over here. Okay, or should I use different pen so that you guys will be able to figure out where I'm trying to mark? Okay, so this little portion over here is being shaded in set C alone. Okay, and at the same time, the little portion over here is being shaded as well in A union B complement. So therefore, the region turns out to be what? To be the commonly space or region being shaded between the both of them. So therefore, we have to shade the little space as A union B prime intersection C. Okay, so this is where we have to shade. I don't want to use that bold pen. So this is the region I want to shade. Okay, so this is it. This is where we are to shade. Okay, so that is enough. So that is how to figure out where to be shade or the region to be shade depending on the particular operations given to you. Okay, so just like I've said earlier, just do this one after the other. Okay, so because using these particular techniques will make it more easier for you to know the exact region to be shaded. Okay, so now let's try to work out one more example. By the way, if you haven't subscribed, make sure you do that now. Okay, if you like my video, please always give me a thumbs up. Okay, because that's exactly what will be inspiring me to create a lot of more content for you guys. Okay? So thanks for watching my video. I really appreciate. So I want you guys to use this as an exercise. Okay, so I won't be solving it anymore. So try to provide the region to be shaded for this particular operation. A complement or A prime intersection B prime, okay, then intersection C prime. Okay, so try to use the techniques we used in this video, then hopefully you are going to get the exact region to be shaded for this particular operation. It is very easy and straightforward. So if you want me to review it, feel free to comment it, then I will review it and give you your feedback. Thanks for watching my video once again. See you guys in the next video.